times the height. And how do you find the area of a circle? That's it. And so pi r squared times the height. And so you can take a look at this animation. And what this shows you is that... Oh, that didn't animate at all. Just did it. Let me just try that again. It used to be animated. Maybe it's because... Oh, let me just check. No, it's just not animated at all. That's a shame. I think this website updated it or something. Oh, hang on, maybe it's my thing because I don't flash. Is that it? Run flash. Will that work? Who knows? Anyway, so a cone, if you boil it down, is 1/3 of a cylinder. And so if the volume of a cylinder is pi r squared h, then the volume of a cone is 1/3 pi r squared h. And I believe you're given that formula, but that's it there. So the volume is 1/3 of pi r squared h. So any idea how you could use that to find the volume of this cone? That's it. Do you have a calculator? That's alright. 16. That's divided by 3 is 4. 4 cubed, so 64. So that would be 64 pi exactly. And then you would just... So if they wanted the answer in terms of pi, the answer is 64 pi. And then if they wanted to 1 decimal place or something, you just put that in your calculator. Okay, volume of this cone. That's it. So you just have to half it to get the radius. That's fine. Put that in the calculator. This one. Yeah, that goes in the calculator. Okay, total volume here. So it wants the total volume, the like red volume. It's not 3 squared. The radius. Yeah. That's it. So it'll basically be times 3 for one of them, and then times it by 2, and would get like doubling your answer. And so it'd be essentially, yeah, times 6. And that goes in the calculator. Okay. Exam question. Mm-hmm. Mm-hmm. That's it. Goes in the calculator, you get the answer. 3 sig fig. Okay. How about this one? Volume of this cone. Yeah. Yeah. That's it. Equals answer. And so the height is the square root of that answer. And then, yeah, so volume is 1/3 times pi times 5.7 squared times That one. Okay. 382. Okay, volume for a sphere. This is your formula. How would you do this? Yeah. I can see the answer. That's fine. How about this one? Yeah. Okay, how about this? Total volume. Any idea what the radius would be? So the radius is from the center to the circle. And so because it's a circle, same way all the way around, it would be the same as that length there. So the red length and blue length are going to be the same. They're both radiuses. That's it. No. Yeah. Something's missing for the volume of the cone. That's it. Yeah, that gets you answer 2, and then you just add those two together and you get your final answer. Any questions there? Okay, and so like a sphere is a 3D circle, and so yeah, from the center to any part on the circle will be it. That's wrong one. Okay, how do we do this? Exam question. Yeah. So the height of the cone isn't 22. That's the height of the cone and hemisphere. Times 15. Yes, you'd take it away. and down. That's it. Any questions there? Yeah, so you just have to watch that thing. Slide 4. Pyramid. It's probably not going to animate, but it's the same thing. So it's inside a cuboid, and if you boil it down, it becomes 1/3 of a cuboid. So you find it's just the volume of a cuboid times 1/3. How do you get volume of a cuboid? Yeah, that's it. And so, okay, find the volume of these two. Yep. And so that'd be non-calculator. What would that be? Yeah, that's 15. And you're going to be fine for the next one as well. Okay. Let me just check. Okay, yeah, let's try this one. So the frustum is like the base of a cone. Any idea how you could do this? For what? Yeah. Yeah. So that would work if it was a cone, but this shape on the bottom isn't a cone. The way you can do it is you can find total volume, and then you can find the small cone volume, and then you can subtract them. Uh, 15 squared times 40. Yeah, so that'd be the volume of that'd be total volume. Yeah, this thing here. The radius won't be 15. Why is that? Well, this height was 40 and this base was 30. So What's the relationship between the height of the total cone and the height of the top cone? No, just the relationship between the two heights. Total cone and top cone. What's the relationship between the heights? Yeah. So that little cone is half the height of the total. Any idea what the radius would be? Or what the base of the little one would be? Yep. So basically, it's like similar shapes. They're similar solids. Basically, this one it would be like the total cone is an enlargement of the little one scale factor 2. So if it's half the height, it'll also be half the radius. Mm-hmm. Yeah. And that would give you the answer for the frustum. Okay. Any questions about that? I think I just realized something about this cone. So if this is just half of it, scale factor half for volume, I think you could just find the volume of the total. So the volume of the total cone, and then times it by, if the little, oh no, because it's the frustum, we're not finding. Oh yeah, so you could just, the total volume, take away the total volume times a half cubed. I think that would work as well. I think basically the volume of this little one is gonna be the volume of the total one times a half cubed, because you know how with yeah, basically total volume minus total cone minus little cone equals frustum. That's how you do it. Yeah, that's that. And I just want to take a look at the other exam questions for it. So there's that one. Just want to see. So a hemisphere and a cone. So we did one like that. Yep. Hemisphere. And wants to fill 12 hanging baskets with compost. Hemisphere of diameter 40. Hanging baskets. Okay, so I think you're going to be fine for those. Upper bound stuff is a bit different. Solid wooden sphere. It's a bit different. Solid cylinder. So that's surface area. The solid is made from a hemisphere and a cone. The cone has a height of that. The volume of this cone. Okay, that's a good one. Try this one. And give your answer in terms of pi. So it could easily be a non-calculator. Okay, any idea about how we go about this one? Mm-hmm. Yeah. So the radius squared is the volume over 1/3 pi h. So what would that be for this one? What is h? And what else would be there? Yeah. Anything we can do to simplify this? And you can simplify something else. Yeah. And how do you do 27 divided by a third if it was non-calc? Yeah. And so what is that? So that's 81. Okay. So is that the radius? That's it. So R equals... Yeah. Okay. We're trying to find the total volume. Hold on, it's not 9 squared. Volume of a sphere. No, 9 r cubed. I think they give that to you anyway, though. Okay. So what is this going to be? And then divide it by 2, you're right. Okay, so how do we do this? I believe so. I don't know if it makes it easier, but instead of divided by 2, you could say times a half. And maybe I'll just write it as times 9 times 9 times a half. Anything you can simplify there. Okay, hang on. What you could do is, you see the way it's like 4 over 3. So maybe, so if I just wrote 9 divided by 1 is 9. So if I wrote all those over 1, pi over 1, this whole thing will simplify to 4 times pi times 9 times 9 times 9. And then on the bottom is 3 times 2. So what can you simplify there or cancel down? So let's say this 4 and 2. So that's just going to be 2 on top. How about one of the 9s and the 3? Not 6. Yeah, that's it. And so that might be a bit easier to work with. Instead of trying to half 729, you could do 2 times pi times 3 times 9 times 9. Yeah, 486 pi. And so they want total volume. Yeah. What you get there? And the hundreds? Yeah, that's it. 756 pi. Yeah, so this one you just had to work backwards to get the radius. And then once you had the radius, use that to get the volume and add them together. Any questions about that? And some of it was just kind of the, trying to not get lost in the weeds of all the little bits and, multiplying and stuff. So that was that. That was, okay, hemisphere. Just want to press this. I think you'll be fine for that. Hemisphere and the cone, you're okay. We did that question. Did it? That's it. Okay. You're gonna be fine, I think. Let's say solve B. How would you solve B? I think this is non-calc. So how would you do 8 divided by 3/4? I think an easier way to do this would be flip both sides. So what would you get if you flipped both sides? Yeah, and then how would you do that? And so how would you get x? Yep. How do you do that? Or what is it? What you could do is write 8 as a fraction. So 8 divided by 1 is 8. So you could write it as 8 over 1. And that's fine. You could leave it like that. Or you could say 10 and 2/3, same thing. Yeah, so it's easier to get the unknown on the top, so you'd flip both sides to get the unknown on the top. Any questions about that? And yeah, you can write it as a fraction. Any whole number can be that. Scale factor of enlargement here. No. Oh, maybe we need to do that then. So that's 2, that's 3, that's 4, 6. You haven't done enlargements before? Okay, how would you reflect this shape in the mirror line? Yeah, and how far away from the line would it be? So the way I'd do it is, so the blue point is 1 to the right of the mirror line. So I would do another 1 to the left of the mirror line. The red point is 3 to the right of the mirror line. So I'll do another red point 3 to the left of the mirror line. And then the green dot is 3 to the right of the mirror line, and so that's 3 to the left of the mirror line, and then join them up. And so just do it corner by corner, and then just draw your thing. So how would you reflect this in the mirror line? Mm-hmm. Yeah. That's it. Okay. And so that's your reflection. Okay, I think you'd be fine for that. How would you do this? So although these numbers are here, it's actually 2 squares away. Like this is at -2. And so which one is the y-axis? That's it. And so yeah, that's 2 away, so you do 2 to the right. How about this one? Yeah, that's it. And this one? Yeah, and then you just join them up. So y-axis, you reflect it that way. If they want x-axis, it would be reflected down here, something like that. But anyway, they don't want that. That's the same, more sides, but it's the same idea. How would you do this one? Well, where is, let's say if we were to sketch the line x equals -1, how would we sketch that? Or draw it. And is it going, is a horizontal line, vertical line? Like that, is it? So that would be y equals -1, because it's going through -1 on the y-axis. They all have y coordinates of -1. So it would be like this. -1 on the x-axis. And so all the x coordinates there are -1, -1, 0, -1, 1, -1, 2. And so that's the line x equals -1. Okay, reflect the shape in that. Right. How many squares away from it is it? So it's 4 away from 0. So this is at -1. So these numbers here are just in the way, but there's another square. Yeah, 4, 5. So it's 5 to the right, and so 1, 4, 5 to the left. How about this one? Yeah, 1, 2, 3, and so on for the rest of them. That one's going to be 3 from there, and the other one's going to be 5 from the other one. And then you join them up. 1, 2, 3, 4, 5. Any questions about that? And so I think if they had given you the mirror line, you'd probably be okay. The trick there is that if they tell you to, reflect it in the line x equals -1 or y equals 3 or anything, just draw the line, draw the mirror line, and then reflect it in that line. Okay, so this one I think you're okay. Where it gives you the mirror line, I think you're fine. These are just, fancier shapes, but it's just the same idea. And they're all exam questions. Any idea how you reflect this in this line? This one, is it? So the way you do these is because it's diagonal. So you're always going perpendicular to the mirror line, so let's say this one, you're always going like head on to it. And so because this one is diagonal, you count how many diagonals away it is, because you're reflecting it head on, perpendicularly. So how many diagonal squares is it away? Let's say this one. How many diagonals away is that? Yeah, and so what would you do? Yeah, so this one is a half away, and so you do another half there. So that one's 1.5 away. Yes, you continue diagonally. That's a half, and then 1. Then how about this one up here? Yeah, so that's 1, 2.5, and so you go another a half, 1, 2, and you put it there. And then you have your 3 points, and so you just join them up. So if it's a diagonal mirror line, you just count the diagonals this time. You're always going, perpendicular to it. You're always going head on. Any questions there? Okay. Next thing is translations. Any idea what this means or what it's about? Yeah, it's like a slide. So how would you slide this -3 to? Right. So let's say this top point. So this -3, 2. The way vectors work is the top one is x, the bottom one is y. But because it's a slide, it's not a coordinate, so it doesn't mean go to the coordinate -3, 2. It means go -3 along x and 2 along y. 2 up y. Yeah, that's it. So it would go 3 left to -2 and then up 2. Okay, so this one. Yeah, that's it. So you do that for every point. So 1, 2, 3 left and then up 2, and at the end just join them up. Yeah, and so if it had been -2, it'd be 2 down, +2 is 2 up. If this had been +3, it would have been 3 right, -3 left 3. Any questions there? Okay, so let's try this one. I feel like we can start with that point there. Left or down? Yeah. 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 And let's say last one. Yeah, that's it. And so it's the same for all of them. 3 left, 1 down, and just keep doing that. Okay, so this is the same idea. 3 left, 2 up. What would this be, just in terms of what direction would it move? Yeah. And 2 down. Square Square A. No, that's easy. Working backwards. So this one I can't do without the tracing paper. You would use tracing paper for this. But any idea what type of... There's two things you could say about it. What type of rotation has happened? Any idea what has happened to Q to map it onto R? Like, how has it rotated? Yeah, anti-clockwise by how much? Yeah, anti-clockwise 90 degrees, and then you would just put down your tracing paper and you'd work out what the center of rotation is. And it might be, you usually start from 0, 0, put your pen on 0, 0, turn it, see if that works. And if it's too low, move up, that type of thing. So this one was from B to C. I think that's all right. So how about this one? From A to B. What rotation has happened there, or what's happened there? That's it. Clockwise 180 degrees, and then you would have to say what the center of rotation is, and it looks like it's 0, 0 again. No, maybe 0. So yeah, 180 is actually special, where it actually doesn't matter. Both clockwise and clockwise will work. Yeah, but 180 is the only number that's true for. Okay, how do you do this? Right. So you have to shade some sectors in. So if you did that, then basically it would have no rotational symmetry, because if you turn it around, it doesn't land on top of itself until it goes back to its original starting point. So you need to make some pattern that will, like, when you rotate it, it will be perfectly on top of itself 4 different times. So like that, is it? So that would have a rotational symmetry of 2, because there's 2 places, like where it is right now, and if you turned it 180, it would be perfectly on itself. But if it was at the top, it wouldn't work. That would be, that would look like a different shape if it was like that. So that's a rotation symmetry of 2. That's right, yeah. Perfect. So it'd be like that, and that's the only way you can get it to have a rotational symmetry of 4. So basically, as you turn it, it will be perfectly on itself again 4 times. So once, twice, 3 times, and then back to the original will be 4. Any questions there? Okay, so then this one, similar, this time rotational symmetry of order 2. That is it. Left and right, yeah. And that would be order 2. So you spin it 180, it'd be on top of itself, and then go back to where it was in the beginning. That's it. Okay, an enlargement of this triangle, scale factor 2. Any idea what that's about? You just double all the lengths. So this one becomes 4, this one becomes 2, 1, 2, 3, 4, 5, 6. This one becomes 6, and then I don't know what the last one is, but you don't have to. You can just join those up. So that's an enlargement of scale factor 2. That's all there is to it. Okay, so enlarge this scale factor 2. It's already down to. Yeah. Yeah, that's it. And then just join them up. Any questions about that? Okay, that's all there is to it. This one, scale factor 3. All right. How do we do that? Mm-hmm. 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 Yeah. Yeah. That's it. Okay, so fancier shape, exact same idea. So just fancy shape. Okay, how about this one? Yeah. What do you mean? So the way I would do it is I would look at the height of the triangle. So the base was 2, that's now 4. The height is 3. And so where would I put that? That's it. That's it. So you just do that as a little scaffold. Yeah, and then so there's other fancier things you can do with the diagonal, but that's probably the easiest way of going about it. Just, you know, the height is 3, so for this one the height is 6, so find the midpoint and go up 6. And nothing wrong with leaving in your working out, whatever it might be. Any questions there? Okay. Okay, how would you do this one? I think what might help is, so similar to the previous one, if you did that, kind of help. So it'll be up 4 squares. So let's say, let's pick here. So 1, 2, 3, 4. Okay. So it was 2 squares to the left, but it's been so the enlargement be. Yeah, so you'd find the midpoint, 2, 3, 4 squares to the left, and then to the right. Yeah, and so 1, 2, 3, 4, 5, 6, and then. Yeah. Okay. Yeah, so it helps to do that scaffolding thing if you ever have diagonals. Any questions there? Okay, and that's the hardest type, I think. We better. Maybe we'll get it next time. Hang on, I just want to check. These are all similar. We'll get it another time. Yeah, how was that for you, Andrey? So, okay. Is there anything in particular you want to do next time? Okay, so I'll try to get something challenging. Any questions for me in general? Okay, well done, Andrey. You did great. I look forward to chatting again next week.